Yeah, comes on everyone. Let's start off. Great. Hope everyone has gone through the notes. So last class we have done some basic math. We did trigonometry, some basic applications. Like I said, last class and today's class, right, is mostly about some of the math things that are going to come in physics. So last thing we did was a little trigonometry. If I know there are one or two new here, so it's really not too much. You can just go through the notes and the recording. That should be sufficient. So it's not like really missed anything. All these are some basic concepts there. And then we did something in infinite GP. So this might be a little new, right? So please make sure to go through the notes and the recording. Hope everyone has done that. And I also gave 2, 3 homework questions, right? We will discuss them at the end of the class. Okay. And also I gave an assignment sheet that also we can discuss if you have any doubts at the end of the class. So great. So we'll start off with the class. Let's not, we'll start fresh with something new. Great. So we'll be learning something about called Cartesian and polar coordinates. Now, this is something important. So the most common system, right? When you say a coordinate axis system, hope everyone can hear me and you can see what I'm writing here, right? And you need to keep your cams on. If your cams are not on, you'll be removed from the classroom. Just give me a minute. Just let me take the attendance. Okay. Again, for anyone who has joined for the first time, right? So few things. Don't worry about writing the notes. You will get the PDF. So your job in the class is primarily to listen everything, understand, and all the time that I'm giving you is to think. Right? If I give you a question and if I give you 2, 3 minutes, I want you to think. So don't waste your time writing the question. You will get the PDF. If there is any important result or something, you can just note it down. Have a book beside and can just note down few important points. Right? So don't waste your time writing notes, making short notes and all that thing. It's a waste of time. Maybe in school it worked. It doesn't work here because in physics, if you start making a short notes, you will literally write the entire notes again. Getting it? So that is few things. Keep in mind. I'll give you a break somewhere in the middle. Like I said, today also we'll not have a full class. I'll leave you maybe by 10, 15 or 10:20. But next week onwards, we'll have it full fledged till 10:35, 10:40. So that I'm giving a week time to get used to it. Right. So anytime you have a doubt, don't hesitate. Please unmute and ask. You're hesitating, you can always, message in the chat box. You can just leave a doubt there. As just said hi. There are 2 accounts of mine, host and the co-host. You can send it to the co-host. If I give you a question, please make sure to answer it. Don't shout it out because let others also try. Right. So few things you'll get used to it. Anyway, so what is this coordinate axis system? It is a mathematical notation to locate a point. So basically, it is a way of giving an address. If I ask you, where is your house? What do you say? You will say, my house is in Ghatkopar, so and so street, so and so building, so and so floor, so and so room number. Right? So you are giving me some information from which I can find the address. So same way, we have different kind of coordinate systems. We have infinite coordinate systems. Getting it? But in school, the most easiest one we studied is your Cartesian coordinate system. So in physics, right, we are going to use extensively. One is called coordinate system. The other one is called polar coordinates. That's where we're going to focus more on today. And you might think like, oh, what is polar coordinates? Looks new. It is actually not new. Ever seen a globe? On globe, when you want to find a location, what do you have? You have longitude and latitude. What are these exactly? These are angles, isn't it? They're not your x and y coordinates, isn't it? So the coordinates on a globe, what you see is actually polar coordinates. What you're seeing are angles. So that's a different way of representing. So just to give an example, when you say in Cartesian coordinate system x and y, if someone tells you there is a point P 3, 2, what is the meaning of this? How do you read it out? The meaning of this thing is 3, 2. This is how you read it out. So from origin, move 3 units along x-axis. Then walk 2 units along y-axis. You could have walked in the y and then x also. It would work. And then you reach the location. That's it. That's the meaning of 3, 2. So it is telling you along x-axis, walk 3 units. And from there, walk 2 units. And then you'll reach the address of point P. Making sense? So that's the meaning of the coordinates x, y. So when you say x, y, you're saying walk x units in x-axis and y units in y-axis. Now in a Cartesian coordinate, best thing to think of is a graph paper. If you look at your graph paper, that whole thing is your xy coordinates. So in a Cartesian world, whenever you're walking, you're always walking either along x-axis or y-axis. For example, if you want to go from A to B, right? And when I tell you to go from A to B, this is how you walk. Huh? You can't go like this. You can't go through the middle of the roads. Either you walk along x-axis or you walk along y-axis. So maybe you're going like this, you're going like this, or maybe you're going like this, and you're going like this. So this is acceptable. This is fine. Or maybe you could have gone like this also. You could have gone straight up. Then you could have gone here. You could have come down. You could have gone here. You could have come up. You could have gone this way. You could do anything. But just make sure you're always going along x and along y. So you cannot travel in any other weird direction. So in a Cartesian coordinates, we travel along x or y. You just cannot go through the middle of the road. You know, how is this thing looking like? This looks like Bangalore city. If you ever been to Bangalore, right? The city is like this only. It's like a grid. They didn't plan the city, nothing. They just built everything randomly. And because of this, you get a traffic jam at every point. You get a traffic jam here, the traffic will spill over here. This road gets blocked, that's why this road gets blocked. This gets blocked, this gets blocked. The whole city is blocked. Right? You want to go for 1 kilometer, you have to travel almost for an hour for 1.5 kilometer in certain sections. It is a mess. So whenever you think about a Cartesian coordinate, think about Bangalore. Right? Bangalore. Just a thing, not exactly. Clear? So this is a two-dimensional Cartesian coordinate. So if I take a 3D, so any doubt so far? Basic stuff, right? This is how you draw a cube. In case you don't know, you can put two squares and then just join them and you get a cube. When I was in 6th standard, now we finished 5th standard, and after holidays I came back to the school and I was in 6th standard. So one of my idiot friend, right, he tells me, Arun, you know how to draw a cube? I said, I don't know how to draw a cube. Then he's like, you're gone. The teacher is going to kick you out now, right? They're going to shift you back to 5th standard if you don't know how to draw a cube. I was like, Arey yaar, please help me now. Tell me I don't want to go to 5th again. He said, fine, I'll teach you how to draw a cube, but what will you give me? I said, what do you want? I want 2 samosas and 1 sharbat. So during that time, it was samosa used to cost 25 paise and sharbat is 50 paise. So that's 1 rupees. So my pocket money for every 3 days was 1 rupee. So I used to get 10 rupees per month as a pocket money. That's a good amount of money. Yeah? So I gave him and he taught me the cube. He said, okay, draw like this. draw like this, join here, and you get a cube. I said, okay, great, I know now. I said, okay, class started. I was waiting. Teacher is going to ask me. I'm going to tell her what is a cube. I sat down for the whole day. Teacher didn't ask. I said, okay, teacher is busy. Tomorrow she will ask. The next day I went to the class. I was still waiting. Teacher still didn't ask. And then I realized this idiot has actually fooled me. So whenever I draw the cube, I remember the idiot. So anyway, so when you go in 3D, how do you go for an address here? So same story here. So from the origin, you walk x units along x-axis. Then you go y units along y-axis. Then you go z units along z-axis. And this is where you reach the point P. So when someone says the address of point P is x comma y comma z, this is how you walk. Are you guys able to visualize this? So this is 90 degrees here. So that's your point P. Clear? So let's do something here before going ahead. Like I said, cube is one of the most important shape, comes a lot. So we got a cube here. This is x, this is y, and this is z. This is the cube of side A. This is your origin, 0, 0, 0. Get me the coordinates of this point, sir. This is point A. Get me the coordinate of point B, which is the midpoint of the side, right? This point C. C is the face center. You know what is the face center? So cube has 6 faces. Face ka center. Think of this thing. In your room, look at the fan. Your fan is at the center of the ceiling, isn't it? That's called face center, right? Get me those coordinates there. Get me this coordinate here at D. Get me this coordinate here, E. So these are all midpoints there. Get me the coordinates of F. F is the center of the cube. Yeah, get me these coordinates. Easy stuff. Just have to give me the coordinates. Try. I'll give you a minute or 2 minutes max. You got an answer, you can type to the chat box here to the co-host. See, there are 2 accounts of mine, host and the co-host. You have to type it to the co-host. You don't know how to get the coordinates? I'll show you one. Listen, in case you have no idea, I'll show you one. Listen carefully. This is how you have to think, okay? I'm starting from here, x origin. If I go along x-axis, I'm going in which direction? X-axis, right? So which coordinate will change? X coordinate will change. So this coordinate will be a comma 0 comma 0. Makes sense? Now from there, if I go upward, you're going in which direction? You're going in y direction. How much are you going? You're going a by 2, half of the length. So only y coordinate will change. So this will be a comma a by 2 comma 0. Are you getting this? So you just have to ask yourself, how much did I walk from here? And how, in which way did I walk? If you walk in x-axis, change the x coordinate. If you walk in y-axis, change the y coordinate. If you walk in z, change the z coordinate, and so on. Now can you do it? There, in some case, someone doesn't have an idea that's how you do it. So let's just finish it off. Yeah, right, Ishi. You will get this stuff. Get it. This will be important later on. You're going to use this in vectors. So there we will ask questions like this. If there is a line from E to C and there's a line from D to B, what is the angle between them and all that stuff. So this is the foundation for that. So let's get this. Everyone should type your answers. That will be great. I know it is an easy one, but still, if you can type, it will be great. Okay, Anish. Try. I'll give another 30, 40 seconds and I'm going to show you all. Even if I started showing, you can keep doing because by the time I explain, you get another minute there. So position of D is on this side, ka center. F is the center of the cube, right? F is center of the cube. Okay, let's see how to do this thing. I will travel from the origin. I will go in this direction here. I will reach here. So this coordinate will be a comma 0 comma 0. I didn't ask you that. I'm just showing you. From there, if I go up, so I'm traveling in y-axis a by 2. So this coordinate becomes a by 2 comma 0. Perfect. So if I continue to go up, this coordinate will be a comma 0. From there, if I take a turn towards A, now I'm traveling from that point to A in the z-axis. So this coordinate will be a comma A. I hope till here it is clear. So that I got A ka coordinate and B ka coordinate. Now what I will do, I will travel in this direction. Look at the black line. I'm traveling along z-axis. So this guy will be 0 comma A. Then I will go up. Now I'm going in y-axis. So there is no x-coordinate so far. So 0 comma A by 2 comma A means if you want to go from origin to E, there is no need to travel in x-axis. You just need to go in y and z and you're done. And continue going up. You will reach here. This guy will be 0 comma A. And then from there, take a right turn along x-axis, right? So D ka coordinate will be A by 2 comma A. You could have actually gone from A to D also. That also works. Now, after reaching D, let's go towards C. You're getting, you'll take a turn that side. Now, which way are you traveling towards C? You're traveling in z-axis, but negative z-axis. Okay. So that would be A by 2 comma A by 2. Is the C making sense, everyone? If you travel along positive z, keep adding. If you travel in minus z, subtract. So you also have to ask how much are you traveling and which way you're traveling. Any doubt so far with the coordinates? Still, what else we need to find? From point C, I can just come straight down. I'll go to the center. So from C, if you go straight down, you're going in which direction? You're going in minus y direction. So y ka coordinate from C, whatever is the y ka coordinate, from that you have to subtract an a by 2. So we get a by 2 comma a by 2 comma a by 2. I think I got all the things right. I got A, B, C, D, F. Yeah. Any doubts on this? Anyone didn't get any particular coordinate, please ask. You can go any direction. I have just taken one direction. You could have gone straight up also. You could have come like this. It doesn't matter which way you travel. End of the day, you should get the same coordinates. All clear with this? Easy? Clear, na? Prisha? Clear? Easy stuff, right? Taksha? Clear? Ahana? Great. So that's it. That's the simple Cartesian coordinates in 3D, right? The next thing, polar coordinates. Now, Cartesian coordinates, right? We have a problem. If you are going in a straight line, there is no problem. But how do you study? Look at your fan. If you have a fan in your room, how does it go? It's going in a circle. How do you study the fan ka motion in X, Y, Z axis? You can still do it, but it's going to be pretty complex. You're getting it. So it is really not that convenient to study something which is going in a circle using X, Y, Z axis. So we created another coordinate system called polar coordinates. Now you need to understand this coordinate system is simply a way of defining address. Now you can tell the address in different ways. For example, if you go to a small village, right? Let's say if you go to a rural area, small village where there are only 100 families. Now, if you go there and if you try to get an address, so and so street, so and so, no one will understand what you're talking about. But if you go there and tell, right, do you know Subramaniam there who used to work as a headmaster? Oh, uska house na, go straight, take a third turn, uska blue color house hoga. Meaning, you see that the whole address, right? The way of telling address is different. When you go to a city, right, you're telling address in a different way. So and so place, so and so pin code and all. But depending on the location, the address might not be a convenient way to give an address, right? I still remember when I used to go to my village, right? There it used to be like this. Where is the house? Once you enter the village, go to the tallest building you can see. Three-floor building was the tallest in the village. Beside that building, there's a pink color house. In that house, that is the address. Matlab, this is how they used to give the address. Get down at so and so bus stop. Look straight. You will see a big house. That is the biggest one. Uska side में pink color house, and that's it done. Now, I see how vague it is, but it works. So So coordinate system is simply a way to tell an address. So first we will do 2D, then we'll go to 3D. So in 2D polar coordinates, so think about this. Imagine tomorrow you are writing a program for a drone, right? And if you're sending a drone from Ghatkopar to, let's say, CST or something, do you think you can give XYZ coordinates? The Earth is a curve. And Earth, what happens for every 8 kilometers, the Earth actually goes down by 5 meters. So that is the Earth ka curvature. So imagine you're trying to send a drone, kamikaze a drone with a bomb to the enemy, right? And the enemy is in the 20th floor. And you send the drone using XYZ coordinates. Now, what happens? You might think, okay, 20th floor yahan pe hai, but because the earth is going down, it will not hit the 20th floor, it will hit the 25th floor. So if you're writing a program for drones, especially for long distances, or you're sending missiles or artillery over long distances, you have to use polar coordinates because earth is curved, right? So, so what is this polar coordinates exactly? So in 2D polar coordinates, we have two directions. Shlok, you have to keep your cam on or else you'll be removed from the classroom. So just like we have X and Y, we have something called radial and tangential direction. So this is how we represent it, R comma theta. So instead of saying X comma Y, we say R comma theta. This is the way to give an address. So how does a polar coordinate world look like? So let's try to understand the meaning of R comma theta. Example, this is how you give the address. You'll say 10 comma 60 degrees. The meaning of this is draw a circle of radius 10. And then from reference line, rotate 60 degrees. You get the address. So draw a circle of radius 10 meters. We can choose anything as reference. Generally, we choose that horizontal or x-axis as a reference line. So from the reference line, rotate 60 degrees. So this point ka location is 10, 60. Did we find the address? So if someone says 20, 120 degrees, the meaning of this is draw a circle of 20. From the reference line, rotate 120 degrees. So from here, you always have to rotate anti-clockwise. This is the location of the point. That's your address. Is that making sense, everyone? So end of the day, it is just a way of locating a position. So that is the meaning of r comma theta, right? So in this, we have two directions. Let me show it in the next page. So, but I hope you got the rough idea there. I'll give you more examples. So in a polar coordinates world, suppose if someone asks you a graph paper in polar coordinates, how will the graph paper in polar coordinates looks like? It looks like this, concentric circles. This is the graph paper in polar coordinates. This is how a polar world looks like, huh, Karthik?
Sir, in this you won't be able to use 3D space?
We'll do now, patience. I said 2D, right? So
Oh, okay, sir. Okay, thank you.
if you just have patience, we will reach there. I can't teach you 3D directly. So in polar world, right, this is how the graph paper will look like. So in this, we have two directions. Instead of saying X and Y axis, we say radial direction and tangential direction. Again, just new terminologies, but the whole idea is still the same, right? So in radial direction means it is either away from center or towards the center. The tangential direction, we are going to use this again, in circular motion. We have chapters there where we will deal with all this stuff. Comes a lot later on. So tangential direction meaning clockwise or anti-clockwise. Clockwise meaning in the direction of the clock. Anti-clockwise is opposite to the clock. Now, getting it? So that is a direction there. So in this world, how it looks. Suppose if you want to go from point A to point B, you cannot travel however you want. You either travel along the circle or you travel along the line towards the center. Meaning you can travel like this, you can come like this, you can go like this. This is how you travel in this world. Or you could travel like this, straight, and you can go like this, acceptable. Or you could have gone like this also. So in this world, this is how you travel. You always go either in circles or you're going in this thing. How this thing looks like? This thing looks like Chandigarh. If you've ever been to Chandigarh, right? The whole city, they built it like this. They built it in ring roads, inner ring road, outer ring road. And you have sectors in the middle, sector 21, sector 23. So the advantage of this kind of a structure, right? The traffic will always keep moving. The chances of getting a traffic jam are minimal. You can move a lot of traffic without stopping. Yeah, but the problem is you might have to, spend more fuel, but the time saves. Meaning if you've ever been to Hyderabad, right? In Hyderabad, you have something called an inner ring road. You have something called an outer ring road. Then they have something called outer or bigger ring. They're just making bigger and bigger roads. Now, we can't do that in Mumbai because we have a ocean on one side, the Arabian Sea on one side, and it's an island. So in Hyderabad, right, something interesting happens. Let's say you want to go from here to here. You want to go from here to here. Right? Hyderabad is big. So if you go from one corner to one corner, that will be almost 70 to 80 kilometers. Right? So if you want to go from here to here in the middle of the day during traffic, if you go through the middle of the city, right, it takes 2 hours. So what most people do, they actually get out of the city, they go to the ring road, and then they hit here with a speed of 140 kilometers per hour. So the outer ring road speed limits are pretty high. Some of my idiot friends are there. They drive in the night at 200, 220 on their cars, and that's what they used to do before they got married. And after they got a kid, now they don't do that anymore. But when you're a bachelor, you do all kind of shit things. So you hit 140, 150. That's a minimal speed. If you go 150, still there is some guy who is crossing you and going. And then you reach here. This thing takes 40 minutes. You travel more, but the time is less. And that road has around like 8 or 9 lanes. So you have enough space. Like people hit 200 on that road. And you also get fined. If you go over speed, you get a fine. But these idiots found a way. That software system has a glitch. If you get a fine for one day, until 24 hours, it doesn't get refreshed. That means no matter how many times you violate in one day, you get only one fine. So first you get one fine, and then you just keep speeding up on the road during night. So I'm not sure whether they changed it now. But anyway, so that's how it goes there. So in our direction set, what we take, so we take away from the center as positive. Just like we have positive x-axis and positive y-axis. So away from center is positive. Towards center is negative. So if someone is going away from center, we say it is plus axis. If you're coming toward the center, it is your negative axis. If you're going clockwise, it is a positive direction. If you're going anti-clockwise, it's a negative direction. Why is that? It is because of right-hand thumb rule. You know right-hand thumb rule? Most of us are right-handers, okay? So when you look at this thing, if I make a fist like this, the thumb points towards you, right? When you go anti-clockwise, the thumb points towards you. If you go clockwise, the thumb points away from you. So just a convention. So if anyone is a left-hander here, we are sorry, but right-handers dominate. So we just use right-hand thumb rule. Just a random, that thing there. So no big deal. But I hope everyone got an idea about a polar coordinate, right? What it does. So it simply gives you coordinates in terms of radius and theta. So if I do give you a few more examples, let's say 20, 210 degrees. So this means it's a circle of this thing, and 210 would look somewhere here. So this is how you rotate. You always rotate anti-clockwise. 210 degrees. So this is 20, 210. And so on. Got this? So now what I will do, what if I give you polar coordinates and I want to find Cartesian coordinates? So that also happens. So relation between polar and Cartesian coordinates. So how do you find this? You actually draw both the axes at the same time. You draw your x-axis, you draw your y-axis. And let's say this point is r comma theta. So what you do, understand the meaning of it. R means the radius from the center. So this distance is r. And this angle is theta. So from here, if you drop a perpendicular, this base will be your x coordinate, this height will be your y coordinate. Make sense? That's your x and y axis, isn't it? So this is r comma theta. So from this triangle, we can clearly see sine theta is opposite side, which is y by r. So there, henceforth, you can remember this. So opposite side is r sine theta. So every time you'll not be writing this. Cos theta is x by r. So the adjacent side is r cos theta. And there, this is how you find the x and y if I give you r and theta. Reverse. If I know x and y, then how to find r and theta? So if I know x comma y, so this is r. It's a right angle triangle, x and y. So we get r is equal to root over x square plus y square. And tan theta is nothing but y by x. So it doesn't matter. Like if I give you x and y, I can get r theta. If I give r theta, I can get x and y. Most of the times you deal with 2D polar coordinates. So it's, it's not really that hard. All clear with this? So I'll give you some things now. You have to get me the polar coordinates and the x and y coordinates for this. So if I give you r theta, you tell me what is x and y. If I give you x and y, you tell me what is r theta. Let's say this is 20, 135. So what is x and y coordinates for this? 25, 37 degrees. Hope you guys remember what is 37, 53 ka values.
So can you show the previous slide once?
Yeah.
So for the x component, won't it become r cos theta?
Sorry, that was cos only. I wrote this in. Yeah, that was a mistake. That's r cos theta x is equal to. Clear? Let's get this thing. So 2035, what is x and y? What is x and y? Let's say this is root 3 and minus 1. What is r and theta? There, get me these four. All this starting 1 or 2 chapters, right? They're little basics, but we have to be clear with them because they come a lot. I mean, for example, today when I was teaching your seniors, that's what I keep telling them. So literally, every chapter we kept on referring back SRC. Refer page 56. So some other chapter. Refer page 135, rotation, some other chapter. So we keep going back a lot. Refer page 191, NLM. So if your basics are not clear in the beginning, right? So you will have an issue there. And this just keeps walking. You keep referring. Refer page 3, collisions. Refer page 170. This is actually based on 2 different concepts of different chapter. You will see this a lot. Like you'll keep referring back. So physics mein, that is the thing. As more and more chapters keep piling up, that's when you actually see the true nature of it. In the initial big stages, it looks like very innocent and cute. So Let's get the coordinates. Others also should try to give your answers. Shrikant, answers. Tanmay, Prisha, answers. Anything. I'm sure like you guys are getting this, but just put one or two answers once in a while. Okay, should I show you one? So 20, 135. So how do you do? Just draw a circle. So we got a circle of 20, 135 degrees. So the point is somewhere here. So this is 135, meaning this is 45. So if you drop a perpendicular here, and this is 20, this base will be how much? 20 by root 2, 20 cos 45, 20 sin 45. So I hope you know that. So now just be careful that this is happening in which direction? You're on the negative x and positive y, isn't it? So the coordinates will be minus 10 root 2, comma 10 root 2. That's it. Don't try to go from the formula. Keep it simple. You are on the second quadrant. In the second quadrant, x is negative and y is positive, and the distances are 10 root 2 and plus 10 root 2. Easy? Understood how I got 20 by root 2, right? 20 cos 45, 20 sin 45, and sin 45 is 1 by root 2. That's it. That's how you do this. What about this thing? 25 sin 37. This is 25, this is 37. This is easy. I just gave you so that you can remember these values. 37 and 53. You should remember this. We just use them because the numbers look good. So drop a perpendicular. 25 cos 37 is 4 and 25 sin 37 is 3. So the coordinates are 4, 3. I hope everyone can handle the triangles apart, right? So that much you can calculate, sine and cos. Any doubts on the first two parts? Then what about the remaining two? Root 3, comma minus 1 and minus 2 and minus 2. So let's just draw them. Root 3 minus 1. So x is positive, but y is negative, means you're somewhere here. This is the radius. So when you drop a perpendicular, this distance is root 3 and this distance is 1. So if I just take this angle here, let's just call it alpha. So r will be root over Pythagoras theorem. Root 3 square minus 1 square, that's 2. And tan alpha is 1 by root 3. I don't want alpha, okay? Alpha is 30 degrees. What you want is this angle. You're getting all round. So if that is 30 degrees, this is your theta. So theta must be 360 minus 30. That is 330 degrees. Are you clear with this? Rohit.
So for the second part, was the triangle 25 and 4?
No, wait, sorry, my mistake. It was 20 and 15, right?
Yeah,
Yeah, my mistake. I was just thinking of 37.
thanks.
Yeah, my mistake. That's 20, 50. All clear with C, how to get this? Any doubts on this thing? How am I getting the angles? Radhika, clear with this?
Yes, sir.
Yeah. Ananya?
Yes, sir.
Shrikant? Shlok?
Yes.
Next thing is what? Minus 2, minus 2. This is easy. Minus 2, you're somewhere here. This would be your radius. This is 2, this is 2, so this is 45. The radius will be 2 root 2. And remember, you want this angle. So theta will be 180 plus 45. That's 225. Clear? So that's the easy part. So that's how you convert polar to Cartesian and Cartesian to polar. All clear with the 2D polar coordinates. Now comes the main thing. 3D polar coordinates. So how do you handle this in 3D? Any doubt so far, Dave? Clear, Dave?
Yes, sir.
Manav?
Yes, sir.
Clear. Pratyush?
Yes, sir.
Prisha, clear with this? Yeah, you can nod your head. I'm seeing you guys on the screen, so I do understand. Great. Now, how do you handle 3D polar coordinates? The best thing is your Earth. If you see everything on the Earth coordinates, right? People talk in terms of latitude and longitude. They don't talk about the radius because anyway, we'll assume it is a perfect sphere, so R is anyway given. So in 3D polar coordinates, the thing will be looking like this. So this is how you give the address. R, theta, phi. You get two angles and one side. So R is the radius, theta is your latitude. Phi is your longitude. So on Earth, that is how you get the angles, right? So let me show you how it would look. So if I can't draw a 3D sphere, but we will try to do something like this. So we have one circle like this and one circle like this. So see, so theta is the angle in the horizontal plane. Meaning this is how you rotate. This line is your reference. So you rotate this way. This angle is theta. Now look at this thing. Try to understand the meaning of this address. When you say R, you can be anywhere on the sphere. So it's you can be anywhere on the sphere. When you say theta, so when you rotate horizontally theta, you can be anywhere on this circle. Basically any meridian, isn't it? Meridians and the equator thing. You can be anywhere on this meridian. Now when you say phi, so this is an angle in the vertical plane. You're rotating in the vertical direction now. So there's one horizontal rotation, there is one vertical rotation. So when it goes up like this angle is your phi. And that's your location there. R, theta, phi. So I'll just tell you how it looks. See, you're sitting, right? Put your hand straight, stretch your hand straight. Take your right hand, stretch it in front of you straight, right? So that the length of your hand is the radius. Now rotate your hand towards the right side, maybe by 30 degrees. That is your theta. Now rotate your hand towards the ceiling by 60 degrees. That is your phi. The tip of the finger is your coordinate, isn't it? That is R, theta, phi. You're getting how are the two rotations? So if I tell you this thing, so let's say you're a robot hand, and that's how we give the coordinates. So if I say your length of the hand is fixed, okay, so let's not change that. If I say something like, 60 degrees, 90 degrees, can you tell me where will your hand point? R, 60, 90. Where will your hand point? So put your hand in front of you, rotate 60 degrees to the right, and then go 90 degrees straight. Where are you pointing? Up, right? You're pointing towards the North Pole, like you're pointing to the ceiling. Making sense? Suppose if I say R 120, 60, where are you pointing? So put your hand in the front, go 120. So you have to go behind, right? If you look into my screen, you can see my hand is going behind, and then you go up 60 degrees. So you're pointing somewhere here. Making sense? So you can play around like that, So if you're designing a hand, you can make your hand go in 3D like that. So that's what actually happens. Are you able to see the angles R, theta, phi? So theta will rotate left and right, phi will rotate up and down. So with these two angles, you can get anywhere in the space. Yeah, if you want to go far and close, you change your length of your hand. Are you clear with this? So that is how you travel actually when you're moving around. So your hand is actually going in polar coordinates. So when you want to scratch your nose, what do you do? Right? You actually, if you see, look at your hand, right? You have multiple rotations. Huh? Your shoulder rotates, your elbow rotates, your wrist rotates. There are actually multiple rotations on your hand. So tomorrow, if you're writing a coding for a robotic hand, you have to treat there are 3 different rotations. To make a robotic hand move, right, you need around 26 degrees of freedom. There are 26 different rotations. Think of like this. Your finger is there, even this rotates. So everything rotates. So it's very difficult to make a robotic hand. Great. So you guys got the idea, I hope. This is a little better picture there. So if you have a coordinate like this is the center. This is the reference. This is your theta. This is your phi. This is your r comma theta comma phi. Yeah, it's a little tilted, but I hope you can see how it is moving. Now can you see the coordinates? Got the idea there? Now, what I want you to do, if I give you polar coordinates, can you get me the XYZ coordinates? So let's try to do that. So we have a sphere here. Let's treat this thing as your x-axis. Treat this thing as your y-axis. Treat this as your z-axis. So that's your x, y, z. Right? And let's say there is a point P somewhere here, which is r comma theta comma phi. Again, just to give an idea, you look at your right. Look to your right. That's your x-axis. Okay. Look to the front. That's your y-axis. Look up. That's your z-axis. Now, can you see your x, y, z? You are standing in the center of the sphere. You are the center of the sphere. So there is a point called r comma theta comma phi. I want you to find x, y, z coordinates of the point P. Let's get this. So how do you get a 3D polar coordinates into 3D Cartesian coordinates? If you know r comma theta comma phi, get x comma y comma z. Try. I'll give 2-3 minutes. Think about it. Let's see how will you figure it out.
In the polar coordinate, if
Yeah, you should get x, y, z in terms of r, theta, and phi.
no, sir, in the concept I was like,
Mhm.
if we are observing out of the sphere, then how will we distinguish between phi and theta? As
That
it,
is your choice. Basically, your theta, my theta can be different, like I said. So we always have to keep a reference. What you're saying is true. What is up and down, what is horizontal doesn't make sense, right?
Yes.
Now, if I ask you, draw the map of India, draw the map of the world, what do you do normally? You put Antarctica here, you put India here. Why? Matlab, why can't you draw something like this? Why can't you put Antarctica here and India like this? Who told you what is east, what is west? We don't know, right? It is just arbitrary. You and I decided that is the thing, convention, we stuck to it. So what you're saying is true. So tomorrow if an alien comes and if you say Antarctica is in the south, the alien will say, what the hell are you talking? What is south? They won't understand what is south. It is our own convention. So what you're saying is true. So generally when we say polar coordinates, we treat Earth, the equator as the theta, meridian as the phi. Clear? So it is just a convention. We have to stick to something, right? So yeah. This is your reference line, okay? In case I think I got your point, what you're trying to say. So how do I know which is theta and which is phi, right? So maybe it's like this. Let's do like this thing. I'll draw that also. This is theta. This is phi. Maybe I think this is what you're trying to ask, right? So when you rotate in xy plane, theta, when you go in towards z, it becomes phi. So theta rotates in xy plane. Phi goes towards z. So your x, y, z should come in terms of r, theta, and phi. Let's get this. Again, you don't need any out of the world max. You just need to know right angle triangles, sine theta, cos theta, tan theta, bus. The words and the terms are new, that's it. So, but the math behind it is something which you can handle. Sine theta, cos sine. Nahi, Anish, you goofed up somewhere.
So can you repeat what you want us to find?
Find x, y, z coordinates of P.
Oh, okay, sir.
So the coordinates of P is given in terms of r, theta, phi, but I want you to find them in x, y, z. Anish, you gave x, y, z only, right? It's wrong. That's not right. She got something, r sine phi cos theta, r sine phi sine theta. Nahi, she goofed up. Just check, look at your angles, phi and theta, how you're taking. Nahi, Rohit, that's not the answer. Take a minute more, then I'll show you. It's about drawing it properly. If you can draw it properly, you will see it. It's all right angle triangles. This is what I was saying last time. Remember, in physics, we have two different types of visualization. This is visualization in space. You're visualizing how this guy will look like in 3D thing. Later on, we will see a lot of visualization in time. How will this scenario play out after some time? Without visualization, you can't improve in physics. At some point, it becomes weird. See, I'll just draw a big one, a big plate here. This is your x-axis. This is your y-axis. This is your z-axis. Are you able to visualize how is this? It's like if you look into my screen, right? It's like the book is there and this is the plate. So this is your xy plane and z is coming out of the plane, right? So first thing, so how is your point P here? So you're traveling, first of all, somewhere an angle theta. So this is A, this is O. So when you travel on the x-axis, this angle is theta. Then from here, you are going on a circle to point P. This angle is phi. Now, tell me one thing. From point P, if you drop a perpendicular, do you think it will fall on A? It will fall somewhere on the line OA at some point B, isn't it? I'll just remove this Y here. Maybe it looks confusing there. Can you see the picture there, how it looks? So from point P, if you drop a perpendicular, it's going to fall on the line OA at some point B. This is R. Now, if you take the triangle OPB, sine phi will be BP by OP. So we get BP is equal to R sine phi. But isn't this the Z coordinate? BP is your Z coordinate, isn't it? Do you guys agree with this? So look at this thing. This is Z. This is Z. They both are parallel. This is Z coordinate. Are you sure, everyone? Any doubts on the Z coordinate, please ask me. Any doubts? All clear with us? Radhika, Ananya, Manav, Shlok, clear with us? Then, if you take OB, look at the line OB there again, same thing. Triangle OPB, if you take cos phi, that comes out to be OB by OP. So we get OB is equal to R cos phi. Now, this is nothing, but that is that. Now, I can show it on the same thing, but I think let me draw one more. So now once you got this, now let's just ignore point P here. Let's just focus on point B. So this point B is the foot of the perpendicular from the top. And we know this length here, OB. Now from OB, if you drop a perpendicular, this is theta. So from OB, if you drop a perpendicular to the x-axis, this will form a right angle triangle. Can you see this triangle now? This will form another right angle triangle. You're putting it on the paper there. This is your x coordinate. This is your y coordinate, because that's what is parallel to the y-axis. So this length is your OB. Let's just call this point as D. So now if you take the triangle OBD, cos theta will be OD by OB. This is cos theta, OD is your x coordinate and OB is your R cos phi. So the x coordinate will be R cos theta, cos phi. Similarly, if you take sin theta, that would be opposite side, which is BD by OB, which is y by R cos theta, R cos phi. So we get y coordinate is R sin theta cos phi. Check, those are your coordinates. So if I have to draw the whole picture again, see, I'll just show it the whole thing in one go. We took something like this. Then you said this is x, this is y, this is z. So the point P is somewhere in the air here. So when you drop the perpendicular, it's going to fall somewhere here. This was point B. So from point B, from O, if you join the line OB, and if you keep on extending the line, you'll meet somewhere here A. This angle was theta, because with the reference horizontally, that line was theta. And with this line here, this angle was phi. This was the opposite side. This was a z coordinate, which came out to be R sin phi. This thing came out to be R cos phi. So you're dividing B again into two more pieces. So you're dividing OB by dropping a perpendicular. We got this piece, which is the y coordinate. And we got one more piece. This is your x coordinate. Y coordinate is nothing but OB sin theta, which was R sin theta cos phi. X coordinate is OB cos theta, which is R cos theta cos phi. So basically, this is one right angle triangle, and that's one more right angle triangle. Is the picture clear now? Anyone didn't get any part of the picture, please ask there. It's two right angle triangles there. So when you drop a foot of the perpendicular, it is like this. When you're standing here, if you imagine this, you're standing. Your foot is point B, your head is point P. All clear with this? So there, I'll just put down the coordinates here. So x coordinate will be R cos theta cos phi. Y coordinate will be r cos theta sin phi. Z coordinate will be r sin theta cos phi. Perfect. This is the relation between x, y, z and polar coordinates. All clear with this? Any doubts on this? Clear, na? Tanmay, Rohit, Shrikant, Pratyush, Prisha, clear with this? Ananya, Dave, Manav, clear? Take a break, take a 5-minute break, come back. We'll continue after this. Let's see how can we frame questions on this. We have some really good ones. We will work on that. So any doubts so far, you can ask, or else go take a break, get away from the screen for 5 minutes and come back. Any doubts? Okay, take a break, come back in 5 minutes. You still have, you can stay back after the class and last time there. But go get away from the screen for 4-5 minutes. Yeah, let's start off. So let's see a question based on this. So let's say we have a sphere of radius r. This is your equator. This is point A and this is other scam zone. So what happens here? An aeroplane flies along A to B along the equator. That's angle AOB is 60 degrees. So this aeroplane will fly from here to here 60 degrees. This thing I didn't draw well. So this is O, this is B, this is A. This angle is 60 degrees. So the plane flies from A to B, 60 degrees. Then it goes towards the North Pole. From B to C, another 60 degrees. Right? And then it moves from B to C towards the North Pole. Angle again BOC is also 60 degrees. And then the plane comes back from C to A directly. So it's a full round trip. in the shortest path. Remember, the plane is flying on the surface of the earth. It just cannot go, it cannot drill a hole into the earth and come in the shortest path. So just to mention that plane flies on the surface. So basically the plane, right, is always going in curves. So first question, find the length A to C. So find the line, the A and C ka distance. Find length of the line AC. Find the angle COA and find the total distance traveled by the plane. If it is an exam question, I'll just ask you the total distance. Then you have to find everything. Let's get this. This is, like I said, it's mostly geometry. So you went from A to B, B to C, and A. So total round trip ka distance. Let's see how you do this. Is the picture clear, everyone? So think of like this. The plane is flying from Mumbai to Dubai and Dubai to Moscow. I know we are not exactly on the equator, but something like that. Able to visualize that? So the plane flies along the equator and then goes towards the North Pole. Then what is the length of the line from A to C? Basically, there's a displacement, the length of the line. If you draw a line from C to A, that actually goes inside the earth. You make a tunnel through the earth. But plane doesn't fly like that. Plane actually flies on an arc. So when it is coming back, the plane will fly like this. It's coming in one more arc. So find the angle COA and find the total distance traveled. Try. I'll give you 3 minutes. Let's find the length. Let's start from there. Anyone didn't understand the question, please ask me. Always keep this in mind. If you didn't understand the question, it is my fault. You don't know how to do it, that's fine. We will figure it out. Give it a try. How do we start? I'll tell you something. You can take OA as x-axis, choose that as a reference, right? Can you find the coordinates of A and C? You know, right? You just know we calculated how to get the coordinates. So if I can find the coordinates of A and C, can you use the distance formula? You will get AC ka line. This is the XYZ. In case you want, you can copy it down in case you don't remember. Luckily here I gave you good numbers, theta and phi. Both are 60 here actually.
But sir, wouldn't that give a line, matlab, that would go through the earth?
That was the question, na? Find the length of the line AC.
So it's okay if it goes through the earth.
Find the length of the line AC. Who cares about what it does?
Okay,
If I
sir.
say
Okay.
line
Okay.
AC,
Okay, sir. I thought arc. I was trying to find arcs.
that is the question, na? That is the distance.
Yes, sir.
Don't get confused between question 1 and 3. Question 3 mein it goes in an arc. Question 1, it was asking A to C ka direct line ka length. So that's okay. Yeah, and that line definitely goes through the earth. Think, I'll give you a minute more and then I'll give you the first one ka answer, the coordinates. Everyone should think. That's the point. It's okay. It's completely fine if you don't get an answer. Don't worry about it. Okay, Rishi. Right, Rishi, got it. You can simplify it further though, but okay. We have one answer. We got AC ka length. Anyone else got AC ka length? Rishi got it. AC direct line. I didn't understand your answer, Rohit.
Sorry, sir. I typed it before it. Like I pressed
Okay,
enter by accident.
no problems. Okay, let's see. So first thing you can clearly see here, if you try to convert this into polar coordinates, so the C ka coordinates will be r comma 60 degrees comma 60 degrees. Do you guys agree with this? Because you're rotating theta in the horizontal and theta in the vertical. And from there, we can find out the x coordinate will be, so basically this was your theta and this was your phi. So x coordinate was r cos theta cos phi, right? So that would be r cos 60 cos 60. Cos 60 is half, so that's r by 4. So if you convert this into xyz coordinates, we will get this. And this would be r cos sine theta cos phi, r sine 60 cos 60 root 3 r by 4. Z coordinate is r sine phi, r root 3 by 2. What about A coordinates? We can clearly see the A, right, lies on the x-axis. You can choose anything as x-axis. I'll choose OA as x-axis, keeps your life easy. And so A coordinates will be straightforward, r comma 0 comma 0. Make sense? There is no y, there is no z. You're on the x-axis. So that's your A coordinates, r comma 0 comma 0. So you want to find AC. So A to C, the formula is the distance formula we have to use. I hope everyone knows it, but in case you don't know, I'll write it down once. I will not do it again. So x2 minus x1 whole square, y2 minus y1 whole square, plus z2 minus z1 whole square. So that's your distance formula between two things. So you're done. So substitute. You can take any one. So this is root over r minus r by 4 whole square, 0 minus root 3 r by 4 whole square, 0 minus r root 3 by 2 whole square. You can simplify this. The r comes out of it. This will be a root, that is 3 by 4, that's 9 by 16, plus this is 3 by 16, plus this is 3 by 4. That's 9, 3, 12, and that would be multiplied 3, 4, 12, 12, 12, 24. So you'll get root over 24 by 16. That would be root over 8, 3 by 2. So this is r into root over 3 by 2. That's the length of AC. Yeah, R is 6,400. That's okay. You can ignore it. Yeah, let's leave the answer in terms of R. But everyone clear with this? Once you know your polar coordinates, it makes your life easy. So polar coordinates is the main theme there. If you don't know polar coordinates, you can still do. You will literally do the geometry part. You know, the picture which I showed you here, drop a perpendicular, then draw a triangle, do all, you would have done all that stuff. Any doubts on this? How do you find the angle? Because see, if you can find the angle COA, then I can say AC is an arc length, right? I can say R theta. So if you know the angle, the third part gets also covered. How do I get the angle from COA? You know everything, right? Look at this. Draw the triangle COA. If you draw the triangle, I know it looks something like this. This is O, this is C, this is A. When you join the line, this is R, this is R, this is R into root 3 by 2. And I'm asking you to find this angle. Can't you find this angle? You can use cosine rule. We can use cosine rule. And this is also isosceles triangle. There are a few ways to do this. You can drop a perpendicular and you can get the angle from there, or you can use cosine rule. There are a few ways you can get the angle theta. You know, three sides of a triangle, you just have to get cos theta. So if I take this angle to be A, if I take this as small a, if I take this as small b, if I take this small c, then the cosine rule cos A is what? B square plus C square minus A square by 2BC. So from here we get cos theta, which is R square plus R square minus 3R square by 4 by 2 into R. That would be 2 minus 3 by 4. That's 4 to 8, 5 by 8. Cos theta is 5 by 8. Not a standard angle, but yeah. All clear with this? Remember cosine rule? You keep cutting. This is what I said. See, I didn't teach you much, but even with whatever little I taught you, things keep coming. So this is your cosine rule in case you don't remember. Page 15. Basic math. And then you're done basically. So you want to find the distance, right? So the whole distance traveled will be RKB, arc BC. This is the first thing that I taught you in the last class. Arc CA, which is arc length is R into theta. Theta must be in radians. So this is R into pi by 3 plus R into pi by 3. And now I know that theta is not a standard angle, so I'll just leave it as theta, where theta is cos inverse 5 by 8. This is how they represent the answer. So you can leave it like this. So you can't simplify it further. Normally in the exam, they'll give you the value, then you can do it. Or else you can leave it like this. So this will be R into 2 pi by 3 plus theta. That's your answer. That, did you see? Once you got it, the angle, everything becomes easy. The distance will be easy. But you need to know the two parts. You need to know AC ka length. You need to know the angle. Clear? The most common misconception, na, people think since that is 60, this is 60, this also has to be 60. Not necessary. Getting it? All three need not be 60. There's no guarantee they'll be 60. Any doubts on this? All clear with this question? Got the coordinates? Great. Let's see, just so that you get used to it, I'll just tell you, just do it roughly and tell me what will be the answer for this. Same story. So you're rotating this time 37 degrees and 53 degrees. So the aeroplane is going from A to B, 37 degrees, then it goes to C, 53 degrees. Just find the length of the line AC. Just do it roughly. So angle AOB is 37. Angle COB is 53. Find the length of the line A to C, the displacement basically. Let's get this fast. I'll give you a minute. There's nothing there, just formula substitution. Again, in case you forgot the formula, these are the coordinates. You can note it down in case you don't remember that. X is r cos theta cos phi, y is r sin theta cos phi, z is r sin phi. Yeah, let's finish it off fast. Okay, you got a good number. Let's see. Okay, Karthik says something. Anyone else? We need one more answer to verify. Okay, let's get the coordinates. So what is A ka coordinates? R comma 0 comma 0. What is C ka coordinates? R cos theta, that's R cos 37, cos 53. R cos theta, cos phi. And then R sin 37, cos 53. And R sin 53. So 37 is how much? Cos 37 is 4 by 5. Cos 53 is 3 by 5. So that's 12 by 25. This would be 3 by 5. 3 and 4. That would be 9 by 25. This is a 4 by 5. So yeah, numbers are bad. So when you take the difference, the distance formula, that will be r minus this. So that will be 13 by 25 ka square. When r comes out, this will be 9 by 25 ka square. And this is 4 by 5 ka square. So you can take out r by 25 common. That will be 13 square, 169 plus 81 plus 400. That would be how much? 118, 170 and 80. 250, root 650. I'm getting something like this. No? Yeah, you can verify the answers. The 12, not 13. We have to do the distance formula, right? R minus this, na? X2 minus X1 plus Y2 minus Y1 plus Z2 minus Z1 whole square. Right, Ananya? Or did I goof up somewhere? Yeah. What is the point? If you just square this, you're going to get R only, right? Obviously, because that is a radius ka thing. You have to subtract, no? You want AC ka formula there. So there, I think that is the answer there. So you got it. Clear with this? That's it. So that's a little bit about the polar coordinates there. Now, other than this, right, we also have other kind of systems. There's also something called cylindrical coordinates. We're not going to do it, but I'll just show you how it looks. So I said, when can you use Cartesian coordinates? You can use when things are going in straight lines. When do you use polar coordinates? Look at your fan when things go in a circle. But imagine you want to study, helix. You want to study DNA ka structure. Does it go in a circle? Does it go in a straight line? No. Did you ever see when you go to a mall, did you ever see the parking? The car goes, like this. If you ever been to a parking lot in the 5th or 7th floor, the car is just going round, 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 round. So if you want to study the motion of the car, do you think circles will work? This is a circle which is going up, right? Becomes difficult. So we define something called as cylindrical coordinates. So in cylindrical coordinates, the world will look like this. It will be a lot of cylinders. So in this world, everyone is either going on a cylinder or going up and z. So the coordinates will be this way: r, theta, z. So example, if someone tells, we're not going to do this, I'm just telling you, you can create a lot more. So advance mein yahi hota hai. They will give you a paragraph explaining you some coordinates and they'll ask you, let's do it in this. They'll expect you to learn this in 4 to 5 minutes and solve 2 equations. Happens a lot in advance. They will go out of the portion. They will ask you something. They'll not do this in mains and bits, but advanced mains is a pretty common phenomenon, right? So for example, someone gives you 10, 60, 5. So what is the meaning of this? Draw a cylinder of radius 10. On the cylinder, rotate 60 degrees horizontally. When you do that, you'll get a line. So this point can be anywhere on the line. On the line, go 5 units in the vertical direction. That's your address. Making sense? So if you're studying a DNA ka structure, which is a helix, or if you're seeing a car which is going in a parking lot, r, theta, z makes more sense. So you use this kind of a system whenever you're studying something is going in cylinders. Making sense? So your clothes in a washing machine, they're actually cylindrical coordinates, isn't it? When the cloth is just spinning, spinning, spinning and going and sticking to the walls, it's actually going on a cylindrical coordinates. So you can have all these kind of coordinate systems and everything. Another best example, right? Look at a screw. If you look at a screw ka threading, it's actually cylindrical coordinates. We'll talk about a bit of this later on also, but but this much idea you should have. So primarily we are more interested on polar coordinates, especially 2D. 3D, if you know it is good, right? Cylindrical coordinates, just have an idea, don't think like, that a Cartesian coordinate system is the ultimate thing. We just use it because your kids in school, it is easy to understand. We kept X, Y, Z, your life was easy. When you go to engineering, right? And when you do some stuff, I have seen people taking, they take curves as an X, Y, Z axis kind of thing. So the curves become coordinate system. It looks pretty weird. Things go pretty weird, but that's how it goes. All clear with this? So that's a bit of the math ka part, right? After this, we have vectors. So that's the next chapter which we'll be starting off. So we will just do a little intro and then maybe we'll discuss all the homework problems that I gave you. And next class, we will start a full-fledged, vectors and everything. So we'll finish off vectors and then we'll go for calculus. So that's again another complete mathematics-based chapter. So, but we will do that after vectors. So vectors is your official first physics chapter actually. So what we did so far is all just basic math. Most of the stuff, right? It is something I made it up so that because I have seen, when in 2 years of physics, you deal with a lot of these mathematical things I taught you. So it's better you know it before. So if you see that again, I really didn't teach you two very weird mathematical concepts, all basics only. So what's a physical quantity? So any quantity that can be measured and observed in an experiment. Example, mass, force, energy, and so on. So these quantities, you can measure them, you can observe them, right? Then you also have something called non-physical quantities. We don't deal with them. For example, fear, hunger. These things you can observe them in an experiment, but you can't give a unit. For example, are you scared of a snake? You have a poisonous snake, you're scared of it. You must be scared of it. What if there is a wild dog running behind you and barking? Are you scared of a dog? You're scared of it. Now, can you tell me by how many times the snake is more scary than the dog? Can you give a number? Can you tell me the snake is 2.2 times more, scary than a dog? You can't give a measurement. Let's say if you didn't eat food for 2 days, you're hungry. What if I starve you for 3 days? Can you tell me by what factor your hunger increases? So there are certain things you can't put a number to it. These things cannot be measured. So we don't study them. These all are called non-physical quantities. You want to study them, then you have to do arts. So become a psychiatrist or something. We'll not do it in physics, right? So now these physical quantities can be classified into scalars, vectors, and tensors. Now, tensors we will not study. We don't have it in the portion. Even when you go to engineering, if you are doing mechanical or civil, only then you will learn. But other branches, you will really not touch tensors. It's mathematically more little complex, but yeah, those are really fundamental when you're into construction or design and stuff. So scalars, vectors, and tensors. All right. So what are scalars? So scalars are these quantities which require only magnitude. Like if you can define them just with magnitude. A quantity which can be defined with magnitude. You don't need anything else. If I say how much mass you have, 2 kgs, done. There is nothing like 2 kgs from east to 2 kgs from north. It doesn't make any sense. What is the temperature of the body? 20 degrees Celsius. Done. Matlab, there is no direction defined. You can just understand everything with magnitude only. Example, temperature, time. If you think that way, right, even money, right? Money is also a scalar. Imagine money is a vector. Mom gives you 10 rupees from left side, dad gives you 10 rupees from right side. They cancel out and you get 0 rupees. Doesn't work like that, isn't it? So they don't have any directions. Then we have vectors. So what are vectors? So vectors are the quantities which have magnitude, direction, and obey vector laws of addition. This is a very weird definition. Matlab, think about this. I don't know what is a vector, but you're saying it should obey vector laws of addition. So in science, this is one big problem you have. Most of the times you're explaining one English word with more English words. Think of like this. How do you explain someone what is color red? How do you explain a blind guy what is color red? You can't. You don't have words. What will you explain red? You can't explain red. You can't even tell what is red. If tomorrow a first standard kid comes to you and asks you what is force, you can tell him all the big definitions. He'll not understand anything. The best way to make him understand him is kick him and say this is called force. Drag him and say this is pull and push, and he'll like, oh, okay, this is force. Like next time he won't ask you, but he got the understanding. So certain things you can't put it in words. You can't express. You can tell anything, but it doesn't work, right? So that's it. So there are certain things. So to give an example, right? So this is one thing, keep in mind. Whenever you learn something, you'll always learn two definitions. A definition for you to understand, a definition, a technical definition. If you're getting it, don't just mug up the definition. That is okay, but you need to also have a meaning for it. Example, this thing we discussed in before. Everyone knows the word, right? Momentum. What is momentum? Mass into velocity. Great. That's a technical definition. What does it mean? What does it even mean? Momentum, mass into velocity. Great. So what? This is important. So whenever you learn something, always ask, okay, definition is this, great, but what the hell does it even mean? Now, that meaning need not be a definition again. It could be an example. It can be a story. It can be anything, something that makes sense to you to get a feel of it. And this is how I remember this. Okay, this is what I think about momentum. Let me ask you a question. If something is moving with a speed of 1 centimeter per second, can you stop it? 1 centimeter, right? We can stop it. Something has a mass of 1 gram. Can you stop it? So if your local train is going with 1 centimeter per second, you will go and stand in front of it. That's one of the most horrible way to die. The train will crush you centimeter by centimeter. Right? If I send you a bullet of 1 gram with a speed of 1 kilometer per second, you'll go and catch it. Did you see something? 20 seconds before you are damn confident you can stop the 1 centimeter per second, you can catch the 1 gram. The moment I said this is a train, you said, okay, I don't think so anymore. When I said it's a bullet, you said, okay, that's not going to happen. What changed? So when I said 1 centimeter per second, you didn't get scared of the speed. You got scared of the mass of the train. When I said 1 gram, you didn't get scared of the mass. You got scared of the speed of the bullet. So what you're getting scared is the mass into velocity, the momentum, not the mass, not the velocity. So what you can think of momentum? Higher the momentum, more difficult to stop the body, isn't it? So when someone asks you, can you stop? You should ask them, boss, what is the momentum? You're getting the thing. This is not a definition, right? If you write this in the book, you write in the exam, you won't get marks. But we understood what is momentum. Are you getting what I'm trying to say? So make sure you do this, not only for physics or chemistry or maths. Tomorrow, when you go and do any startup or any job or anything, right? If you go to a stage in front of audience of 1,000 and you tell them a definition, no one gives a shit. They'll not understand what you're talking. You have to give them a story. You have to give them something they can understand. Clear this? So always have a definition for you to understand. Always have a technical definition. But I hope the train ka thing was clear, right? So that's a bit about it. So next class when we catch up, we'll continue from here. We will do more of it. So that's little just intro there. But vectors is quite an important chapter. Literally comes in every chapter. This is like your, screws and bolts of physics. Without vectors, you can't handle anything in physics. If your vectors is bad, the whole physics goes off. But not a tough chapter. It's manageable, but you will see a lot of new terminologies. That's what makes it a little weird. But don't worry, we'll go slow. Aram se you'll get used to the whole stuff. Right? So we will do vectors in the next class on. So I will catch up again next Monday. Like our classes on Monday and Wednesday. So we'll see again on Monday. And next week I'll also give you access to the testing platform ka access. So mostly we'll start our tests after next week, so after 2 weeks. Maybe the first test will be only on basic math, like all that trigonometry stuff and everything. Okay, that is one. So with that, we will wrap up for the day. I will discuss the homework questions, but if someone has no doubts, you're free to leave. If you have doubts, please stay back. So if there are no doubts, you're free to leave. So let's discuss the homework questions. The first thing I gave you was this hexagon. Right? So how do we do this? Straightforward. Remember that logic I told you? Instead of drawing the picture 6 times, I can make this argument, remember? So I can just say like this. So this was A, B, C, D, E, and F. So A to F, this distance was A, right? So A to F, this distance was root 3A. A to D, the distance was 2A. C to A, this distance was root 3, these distances are given, this was A. So can I say whatever F does right now, A will do in the second turn? Whatever E does right now, A will do in the third turn. Whatever D does, A will do in the fourth turn, C, fifth turn, B, sixth turn. Therefore, the total distance traveled by A is the sum of the distances traveled by B, C, D, E, F in one turn, right? And what is the angle? Pi by 3. And what are the distances? A plus root 3A plus 2A plus root 3A plus A. That's your answer. All sure with this? So instead of drawing the picture every time, you can just use the argument which I taught you in square. So it becomes quite easy for you. Clear? Then the triangle one. This thing is just you have to do it. So what did you guys get? So the triangle, you just have to calculate here. So the first time this is 33 meters. So when you go here, 33 minus 3, so this is 30 meters. Now this is 25 meters, so you lost 5 there. And then you lost 4 again. That's 21. Then 21 minus 3, you just have to keep counting. So 21 minus 3 was 18. 18 minus 5 was 13. 13 minus 4 was 9. 9 minus 3 was 6. 6 minus this thing was 1. So, and finally you'll hit somewhere here, 1 meter from the top. All clear with this? Yeah, and what about the angle? Now this is a little messed up. Every time you go from here to here, you go 90 degrees. And what is this angle? This was 53. So this angle is 127. What is this angle? This is 37, so this is 143. So numbers are really not that great. That means if you look at the numbers here, whoever was here, they all rotated 90. Whoever was here, all rotated 127. Whoever is here, all rotated 143. You get different radiuses and different angles for each one. All sure with this? So the answer would look something like this. So 33 plus 21 plus 9, that would be into pi by 2 plus 30, 18, 6. That would be 127 degrees. But remember, you have to write in radians. So pi by 180. Numbers are not really that great. You have 25, 13, 1, and that's 143 degrees. You have to convert into radians, pi by 180. Yeah, if you can, it's okay. You can leave it there. But I hope you got the idea there. You keep subtracting the distance and you keep changing the angle there. These two, what else did I give? That's it, right? Only these two questions. And I also gave you 2 sheets, right? So anyone has any doubts in the sheet, you can ask me. If I'll tell you which sheet to wait. Let's do the first Trigoka sheet. In that there are 12 questions. So you can just tell me the number, any doubt on that, 1 to 12, anything.
Sir,
In that, I think the one good question was the 7th one. So, bolo.
So 7, 12.
Yes, sir.
No. We'll go one at a time. Let's not play housey. If you say 7, 9, 79, it'll become a housey. 7? I'm sure 7 is the thing which most people didn't get, I guess. So let's read the question. A flagstaff on top of a tower 80 meters high. So we have a tower which is 80 meters high. It's little terminology here. We have a flagstaff here. So that is a flag. And this guy is subtending an angle of tan inverse 1 by 9. So meaning when you say something is subtending, meaning when you look at the top of the flag and when you look at the bottom of the flag, this angle, let's call it alpha, he's saying alpha is tan inverse 1 by 9. Are you getting the meaning of that word? That is the meaning of angle subtended. When I say you are subtending 10 degrees on me, meaning if you look at your head, if you look at your legs, the angle between those 2 points is 10 degrees. So this is a way of writing tan inverse. That means indirectly tan alpha is 1 by 9. Let's call this angle as theta, and the base ka thing is 100 meters. Let the flag ka height be h. Tan theta will be 80 by 100. That's 4 by 5. Great. I know tan theta, I know tan alpha. So if I take the full triangle, tan theta plus alpha, this will be h by h plus 80 by 100. So far clear, everyone? But how do we get tan theta plus alpha? Remember the formula, tan A plus tan B? Tan A plus tan B is tan A plus tan B by 1 minus tan theta tan alpha. That would be h plus 80 by 100. What is tan theta? 4 by 5. What is tan alpha? 1 by 9. Substitute, you'll get the answer. So in this question, right, there are two important things. One is the word, the angle subtended. That might be new to you. Second, we'll get tan A plus B, which you already know. I taught you in the last class. You have to use that. Clear with that? So if you're done with your doubts, you can disconnect and need not wait. But if you want to listen to all the doubts, you can listen. That's up to you. I won't be forcing you. What else in the sheet for trigonometry?
12.
12. Okay, can I turn the page? It is there in the notes. Huh? I will leave it to you in the notes. You can refer to it later if you want. But in all clear with the 7? Okay, 12th one. Again, it's a little with the picture. A tower of height h standing at the center of a square. So we got a square. And we got a tower here, which is height h. So from this corner, this is point A. So it is making an angle alpha. So if you drop something like this, he's saying this angle is alpha. Can you tell me what will be this length here? This is full diagonal, right? This will be half diagonal. How much is half diagonal? A root 2 by 2. A by root 2. Right, Ahnu? Sure. If you take the full diagonal, this is A root 2. So what will be the half of it? Half of A root 2. So from here we can get cot alpha. Cot alpha is A by root 2 by h. Square it on both sides. Cot square alpha is equal to A square by 2h square. So we get 2 is equal to A square by h square cot square alpha. Clear. Anything else in the trigo sheet?
So question 5.
Question 5. The flight is flying with a 45 height of the... कुछ नहीं picture draw करना था. This is the kite. He's saying kite is flying with a string inclined at 45 degrees. So this is 45. The length of the string is 30. He's asking the height. 30 sine 45 na opposite height. You didn't get the picture, yeah? बस इतना ही था ना. He's asking height. So sine 45 is opposite side by hypotenuse. Right? What was the confusion here? There's nothing there. Like, maybe you got kite and you got scared. So what else? Anything else in the Trigoka sheet? Clear? Then let's see the second sheet, the handwritten sheet. Any doubts on that? That's basic only. So, but still, someone has anything, please ask. Fine, then if there is no doubt you're free to leave, you can disconnect. So if someone has anything else, please stay back.